Okay, so I'm just gonna start the first assignment now. So this one is called Subsets of Sample Spaces. So it reads, Anna and Charles have a bag that contains one black marble and one white marble. They are playing a game where they randomly select a marble out of the bag 3 times with replacement. Anna thinks that the probability of getting a black marble on the first selection and a black marble on the third selection is greater than the probability of getting a black marble on the first selection and a white marble on the third selection. Charles disagrees. He thinks that the 2 probabilities are equal. The sample space of possible outcomes is listed below. B represents a black marble and W represents a white marble. Who is correct, Anna or Charles? Choose one answer. So, I'm going to start this problem. So I'm going to first write out, Anna and Charles have a bag that contains one black marble and one white marble. So I'm going to write down one black and there's one white. They are playing a game where they randomly select a marble out of the bag 3 times with replacement. So each time that they pull a marble out, they always put it back in. So that's an important point there. Anna thinks that the probability of getting a black marble on the first selection and a black marble on the third selection is greater than the probability of getting a black marble on the first selection and a white marble on the third selection. Charles disagrees. He thinks that the 2 probabilities are equal. So the sample space of possible outcomes is listed below. So here we have the first option being black, 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 or then the second option is black, white, black, white, white, black, white, black, white, black, black, white, white, black, 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 white, white, or white, white, white. So basically all I'm going to do is I'm going to count the differences of Anna and her assumption that the probability of getting a black marble on the first selection and a black marble on the third selection is greater than the probability of getting a black marble on the first and a white on the third. So what I'll do is, so she wants a black marble on the first and a black marble on the third. So I'm going to look for everything that has a black marble on the first and a black marble on the third. So my first option being black, black, black is obviously one of those options. Black, white, black is another. White, white, black is not. White, black, white is not. Black, black, white is not. White, black, black is not. Black, white, white is not. And white, white, white is not. So right now, her assumption, so right now, her probability is 2 out of 1, 2, 3, 4, 5, 6, 7. So her probability is 2 out of 8 chances that there will be a black marble drawn on the first and third selection. So Charles, so that's Anna's assumption. So I'm going to write that down. So Charles believes that the 2 probabilities are equal. So he believes that drawing a black marble on the first selection and a white marble on the third selection is going to be equal as to drawing a black marble on the first and a black on the third. So I'm going to count how many options or how many odds there are of drawing a black marble on the first selection and a white marble on the third. So black and white, so I have white, white, black is not, white, black, white is not, black, black, white is, so I'm going to highlight that guy, and white, black, black is not, and we also have a black, white, white option, which also is an option, and then the last white, white, white option is obviously not. So in this case, Charles is correct because there are only 2 options or 2 outcomes where a black marble is drawn first and a white marble is drawn third. So in this case, Charles is correct, believing that the 2 probabilities are equal in this case. So I'm going to select that answer. Charles is correct. And we're going to check, and I'm correct. Perfect.